then it's all yours. Thank you very much, Gavin, for presenting the main topic at this meetup.
Thank you, Derek, and welcome to the Ham Radio, GNU Radio Talk Ham Radio session for December 12th. And I want to say welcome to you from Invermere, British Columbia, Canada. This bullseye shows my location. That's it in Western Canada. If we drill down here, we can get down to Lake Windermere. This is the Canadian version of Lake Windermere. It was named after the UK version. I've been to both and I don't see the resemblance, but that's what it is. So there I am on that little point of land sticking out into the lake. And as I said, this is my ADS-B system, which monitors aircraft passing overhead. So I'm a retired electrical engineer. I've always tinkered with electronics. When I was 10 years old, I built a foxhole radio with a razor blade and a lead pencil, and actually got some static out of it. I never actually got it to receive anything, but that was my first radio project, and that would have been the 60s, early 60s. Now I'm retired. I do lots of hobbies. Every day's a Saturday, but anyway, we keep busy. My projects usually involve hardware and software. If it's a pure hardware project, I don't get quite as excited as if there's some software involved. So I do a lot of work with microprocessors and now Raspberry Pis. And so 5 years ago, when Hank suggested I get my amateur license, I did, and then I found this GNU radio thing, and I was immediately hooked with that. And so we're going to see about that later, but it involves hardware and software. So for me, it was a perfect project. So let's talk about the meeting today. We're all on Zoom, so the etiquette is if you could mute your mic until you want to talk, and I believe there's a button you can push to chat if you want to ask a question or something like that. And although I don't see anybody, but I think you can put your hand up. So I'll try and ask for questions at appropriate times, but otherwise we'll just keep going here. And Derek is my assistant. He's Vanna White today, and you should be seeing a screen share of mine, including this map. And I'm okay, there it is. I see that it is. So this is the Talk Ham Radio, blah, blah, blah. This is what we're going to talk about today. Transmit, receive switching, how I did it, and then we're actually going to do some sort of demo on the 2-meter repeater, which is run by our amateur radio club here in the East Kootenays of British Columbia. It's been acting up, so like any live demo, there could be some glitches. So I'm going to assume that just about everybody on the call has their amateur radio license in their home club or what have you, and that you're familiar with GNU Radio. So I had one person ask me if this would be suitable for newbies or beginners, and I said, no, probably not. So if you're not familiar with amateur radio or GNU radio, then you might find this a little bit daunting, but if you know that, then you'll have met my assumptions. So diving right in, if you have a handheld or a mobile or a base station and you want to use voice, you typically push to talk, and that's how you switch from transmit to receive and vice versa. Now, a lot of other systems use a cat control, but again, it's just one wire that goes from the computer or what have you, and it switches. You look inside those radios, they've probably got some sort of switch inside, an antenna control that switches between the circuitry for receive and transmit and turns on the power amp on transmit and so on. So that's all happening inside the the transceiver that you have for amateur radio. Think about GNU radio. A lot of those things are not obvious how you do it. So when I set out to buy my first SDR, I bought one called a HackRF. And one of the requirements I had is it had to be able to transmit. I thought, what's the point of having your amateur license if you can't transmit? So you can get your little SDR dongles. They're great and they're fun to work with, but if you can't transmit, that's no good. So I bought a HackRF. I wouldn't do that today, but that's what I bought. The other thing you have to do when you're switching is you have to change the frequency and change the mode of the transceiver. And again, that's not obvious how you do it in GNU Radio or any SDR for that. And all the different ones seem to have different ways to do that. So we'll talk about how I did it, and let's dive right in here. So what I did is I have the HackRF1, which is an SDR transceiver, but just out of the box, it was not possible to switch between transmit and receive. So one of the things I did is I took the cover off and I went into the hardware and hacked it so I could bring out a logic level signal that was high on transmit and low on receive. And we're going to see why I did that in a minute. I also split the transmit and receive RF signals and put them on separate SMA connectors. And we're going to see why I did that in a minute. Meanwhile, on the software side, I've got a laptop with Linux running, GNU Radio, use the Osmocom sync and source blocks, but we don't use the native drivers. We use the SOPI HackRF driver, and it was customized by me. The reason is the SOPI HackRF driver that came with GNU Radio and Osmocom didn't work, would not switch between transmit and receive. So I got the source, it's open source, fixed it, and gave a pull request back to the SOPI group, and it is now part of the SOPI HackRF driver, and it works. And I keep getting requests from people on the SOPI talk group saying, you know, how does this work and what does it do? And so when I saw Derek and Barry were starting this GNU Radio talk group and they were asking about transmit receive switching, I thought, oh yeah, I know how to do that. I can tell you, I had to do it. And the other thing I did was I had a stream select switch, which was an out of tree module by myself. And again, we're going to see that when we look at the flow graph. And an out of tree module just means that it's a block that I wrote. And so that, if you know GNU Radio, you know what that means. And the last thing, which is part of the station control aspect, I had this PIC microcontroller, which is a little 8-bit microcontroller that I used to control the power amp. And I had great plans for it, but at the moment, it's just basically a glorified AND gate. But let's see it is. So this is the hardware connections, the laptop computer, the USB connection to the HackRF1, another USB connection to this PIC micro. So here's this logic level signal that comes out of the HackRF1, and it goes high whenever the HackRF1 is in transmit mode. In fact, it's just the wire that comes off the LED that says TX. So I just got onto that. I feed that into the PIC micro, and when things are enabled, it feeds a logic level signal to my homebrew RF amplifier, and it's got a switch. It goes into a relay, and it switches the antenna from transmit to receive and vice versa. Meanwhile, the RF level, the coax This is the new one, the transmit coax. So the transmit RF signal comes out here, goes through a little bit of a preamp there, or a power amp, through a relay out to the antenna, and the received signal comes back the other way. So you get the impression this is not for the faint heart. It's not like push to talk. It's not real easy. And that's pretty much true. Now, how do we get this going here? There's a picture. Oops, sorry about that. This box here is the HackRF1 sitting on the cardboard box that it arrived in. And I just use that as a spacer. And if we look real close, this ribbon cable has the logic level signal that I was talking about. Goes over here to this PIC microprocessor. This was going to be a coupler for a watt meter. Never did finish that, so it's just sitting there for the moment. Power supply. And this is my homebrew power amp. You can see it's got the two RF signals over here and the antenna connection over here. Power coming in. Pretty straightforward stuff after a while. That's the laptop sitting there. That's a USB hub, Ethernet switch. And you can't see it now, but up here, up higher, is a watt meter, which we're going to see in a minute. Now here's down into the nitty-gritty of how we do the transmits and receive switching. So like I said, I'm just going to show you. This is the flow graph, but it's really busy. But you can see here, there's the Osmocom source block, the Osmocom sync block. In fact, they are two separate blocks. And if you know GNU Radio, know that each block runs under its own thread under one top level Python process. So, whoops. So the source block and the sync block are both in GNU Radio Companion process, but they have common code in the SOPI HackRF driver, which in turn talks to the Linux Live HackRF. Pardon me, that's the Live HackRF is the library that came from Great Scott Gadgets for the HackRF. That talks to the standard USB driver, go out the USB port. Inside the HackRF1, there's actually an FPGA, which is Field Programmable Gate Array. It handles the USB interface and splits the signal so that when we're streaming and receive, we're getting a stream of floating point numbers at whatever the sample rate we're using. I'm using 2 megasamples per second. And it switches that when it's in transmit mode. Samples are going the other way, goes out to the D to A. There's a bunch of RF circuitry in there. And now here's the interesting thing here. I don't know, you might have to zoom in to see this. I'm not sure if I can do that, but inside the HackRF1, there are solid state switches. So in receive, there's a switch right there that brings in this little preamp in or out of the receive path. So that's what those two little switches do there. And then there's another switch that controls whether the antenna, the regular antenna port, is connected to the receive path or the transmit path. So on the receive path, the antenna signal comes in through here, optionally goes through the preamp, through the IF and tuner stages, finally into the A to D, gets streamed out, the HackRF1, blah, 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 and goes to the Osmocom source block, and then into the rest of your float graph. When you're transmitting, we get data from the Osmocom sync block through these drivers over the USB through the FPGA into a D-to-A in the HackRF1, some more IF circuitry, and then we come to some solid-state switches. And out of the box, they control whether or not there's a preamp fed to the antenna. But what I did is I hacked it. And this red line is what I did is I cut that trace there, connected with a little capacitor out to an SMA connector out here. So this, whenever I've got this switch, so first of all, when we're transmitting and when the transmit preamp is on, the transmit RF signal will come out this second SMA connector. And over here, this microprocessor runs the whole HackRF1. It's got an LED on it. That's what that little arrow is supposed to indicate. And whenever the LED, the TX LED is on, I bring out this logic signal. So that's sort of the data path of how we do it, but we're still missing the key point, and that is, how do we switch between transmit and receive? So normally with a standard Osmocom block, you can either have a source or a sink, but you can't have both unless you use the SOPI driver. But what happens is, am I getting ahead of myself? No. So what we did in the SOPI HackRF driver, we programmed it so that if there are bytes coming from the sync block, then it will switch to transmit mode, send the appropriate command to the microprocessor to tell the field programmable gateway to switch to transmit mode, and anything that's streamed out of this sync block will make its way down the transmit path. When there's no more bytes or no more data to transmit, the SOPI HackRF driver will revert to receive mode. So that means that all the bits that are coming in here will go to the source block. And that's the crux of it, that when there's data to send, the driver will make the switch from receive to transmit, and will stay in transmit as long as it's got data to send. And when there's no more data to send, it'll default back to receive mode. So if you think about GNU Radio Companion, and I'm sorry, oh yeah, if I do it in PowerPoint mode, it, okay, let's do that. Just bear with me here. I'm going to okay, so now you can see the flow graph in all its glory on my other monitor. And I think you're also seeing all these faces here, right? Just nod. Did everybody see the flow graph?
Yeah, it's coming through.
I do. Yep.
Good.
Yep.
All right. Now, I still can't zoom in, but anyway. On the right-hand side here, this is the Osmocom sync. So this is the this is where all the transmit path ends up. And if we work back, there's a resampler, there's the narrowband FM modulator, there's a multiplier there, which gives me some gain. And then we come to a block that I wrote. This is called the stream select, this one right here. So you can see it's got floating point in and out. It's got 3 inputs, 1 output. The output is what actually goes over here to the it goes up through the gain and to the narrowband FM modulator. So there's three different audio sources that we can feed in. One is, I just got a little sine wave generator here. So if I choose that, then there's a tone that gets put out on the transmit side, signal goes. There's also a wave file, which has got my voice, just says my call sign over and over again. So I can put out an ID. And there's also a UDP source. The UDP comes over the network, which is a little bit overkill in this case, but you'll see why in a minute. The voice comes over the Ethernet network, gets converted to float, and then whatever I'm saying here in the shack gets sent out on the transmit. So normally the switch is in the voice position, and there's nothing coming over the network. So there's no data going to the modulator, no data going to the resampler, no data going to the sync block. So the driver puts it into receive mode. So that's what happens as long as there's no data to transmit. Meanwhile, the source block here, it's receiving the way source blocks do. I'm sure you've all used it. Source block, we've got a translating filter, resampler, power squelch, narrowband FM receiver. It's pretty standard stuff. I also have a tone squelch in there. Don't actually use it because our club repeaters don't have tone squelch. A little bit of gain. And then I use these blocks here to take the audio signal and put it back on the network, on the Ethernet network, the LAN in my house, and it sends it to my laptop computer. So takes a little getting used to, but the reason I do all this is that this flow graph is running on a laptop computer, which is out in the garage, and my shack, so to speak, is in the basement of the house. And I'm a network expert, so I use the network to transmit the audio to and from the flow graph. Okay. Stop sharing that one. Share this one. What you see now is actually the screen of the computer running the flow graph. Well, in fact, it's using a XRDP, which at the last talk, Barry was showing us VNC, how he gets the screen over the network. It's similar to that, but this is because I started using RDP with Microsoft Windows, I found out you could put XRDP on Linux, then that's what I use just from habit. So this is the screen. It's down here in the basement with me, the monitor is, but it's actually the remote screen from the box that's running GNU Radio. So you can see there's the icon and so on. This window here is a webcam viewer, and it's pointed at the watt meter for the rig. So this is a crosshair watt meter. If I'm transmitting, this left-hand needle will go up about a third of the way up the scale to about 12 watts. The right-hand needle, which is the reverse power, will probably bounce a little bit, but the SWR in my antenna is pretty good, so it shouldn't move much. But this is how I monitor it to make sure I'm transmitting. I have to remember to turn the lights on in the garage, otherwise you can't see anything. But that's c'est la vie. This is the actual flow graph that we saw a moment ago. How's my time here? Because I can't see my time on any of these screens. Oh yeah, 9:30. Good. So it's pretty much what I talked about a minute ago, the source block, the sync block. But down here, we have some debug messages coming from the HackRF driver. Now, I told you I had done some work on that, and it's now part of the SOAPy HackRF distribution. And one of the things that I left in there is that if you start GNU Radio with a certain symbol, then the debug messages will come out on the screen. So I've done that today. If you just started GNU Radio normally, you wouldn't see these debug messages, but I've done that so that we'll see when things switch from receive to transmit. Okay. Now here's a program that I wrote called Audio Pipe. And basically, it's the program that interfaces to the Ethernet network. So when I click send, the audio from my headset microphone will go out over the network, end up at the other computer via UDP, and go out on the transmit path. The rest of the time, the receive audio from the source block comes over the network, come back into this program, and will go out my speakers. Yeah, what do I want to see here? Got to get these screens all just right here. There. Okay, so this is the GUI interface on the flow graph that I wrote. And it's a typical amateur radio interface. For the frequency selection for receive, there's a separate frequency for receive and transmit. For receive, there's only three possibilities. There's a repeater, it's about 10 kilometers away, FM simplex number 1, which is 147.42. And the third choice is another repeater that's about 100 kilometers away. Sometimes I can hear them, sometimes not. This checkbox here will turn on and off the receive preamp. Then we have some controls. So for the HackRF one, you can control the IF gain, the RX squelch, baseband gain, audio gain. And then this isn't related to the radio. This is just more audio gain if I need it. So what I'm going to do is I'm going to turn the squelch. Okay, and now down here, this is the frequency spectrum of our received signal. So you can see when I'm on my club repeater, it's 146.85. And this spike here is at the center frequency of the receiver. 146.85, of course, is up here. So it's very common when you're using an SDR, the center frequency for receive, you try and set it about 200 kilohertz away from the signal you're trying to demodulate. Because if your signal was right here, you're doing frequency demodulation, it would be desensitized by this big DC spike. And you'll see that in the SDRs and so on. Some of the more modern ones like the ALM Pluto and the Lime, they've managed to eliminate that spike, but that's neither here nor there. This spike here, that's actually noise in the background. I'm not sure what it is, but it's always there. And right there, 146.85, that's where the receive signal is going to be from the repeater back to us. My transmit's going to be way up here, offset by 600 kilohertz. Blah, blah, blah. Okay, so then we got transmit frequency control. there's the checkbox that turns on the transmitter preamp. And so the signal will go out through my power amp instead before it gets to the antenna. And here's my TX selection. So this corresponds to this select switch here. So I'm in the voice position right now. So that means the network audio that I send goes out through here and out to the transmit. But I'm not sending anything right now. We'll see how I do that in a minute. If I switch to file, it transmits my call sign over and over, and tone is that. So I could turn on a handheld and listen to that, but I'm not going to do that. I'm a little leery of live demos. Things tend to go wrong if you go off script. So anyway, and like I said, here's the frequency spectrum. So I'm going to push to talk. I'm going to send my call sign. What I want you to do is to watch 3 things at once. Over here in the debug message side, you're going to see the message that goes to the HackRF microcomputer saying switch to TX mode. So the last thing that happened was start RX. There'll be something that will say set transmit frequency to something else, set receive amp gain, transmit amp gain to on, start TX. Meanwhile, just getting my mic out here. If you watch the receive spectrum, it will freeze because when the HackRF, SOPI HackRF driver switches into receive mode, it stops sending signals, stops sending any data on the receive path. And this GUI block here is on the receive path, so it stops getting signals. It actually appears to freeze. Now it's still actually running, but there's just no data for it to work. And if you've ever written a block, you know that if there's no data incoming, then there's no data going out. So anyway, I'm going to send something. You'll see this appear to freeze. You'll see that change. When I release, then we will see the kerchunk come back from the repeater, and it'll be right about here at 146.85. And probably it's been more than half an hour since our repeaters had traffic, so it will probably also send an ID. Here we go. This is VE7GSJ audio testing. Over. Okay. Give me a thumbs up if you heard that ID. Okay, good. That's just about it. So that was here was the debug message saying it went to transmit, started transmitting. As soon as I released the send button here, it said, okay, no more data to send, went back to receive mode, switched the frequency, clicked some amps, start receive, there it is. And we saw the receive side giving us some spectrum there, and we heard the ID from the repeater. Phew. All right, I think that's there's one thing I missed. But you'll just have to take my word for it. When I started transmitting, this signal went high, went through the PIC microcontroller, and keyed the power end and set the relay in the transmit position. And so what we should see here it is. I'm going to do one more test. And you should, if you look real close, you should see the needles here flicker on the transmit power, and hopefully not too much on the reverse power. Okay, here we go. This is VE7GSJ transmit test. Over. I know because I was watching carefully. The transmit power gave a bit of a flicker there because there was a bit of traffic on the Ethernet network in the house. And I think it switched back to receive for just about a quarter second or so. But anyway, you can see the transmit power did go out. It's only about 10 watts, which is that the output of my homemade power amp. There's a whole story to that power amp. That's version 4 of the power amp. It was my first RF project, and I learned a lot along the way and learned a lot of what not to do, but I blew up a couple of the chips along the way. Okay, so I'm going to talk about some other things in a minute, but I'm going to open it up now for questions on what we've seen, or if you want to go back and look at different aspects of it. And there we go. Okay, here's some chat messages. Okay, I guess I missed a few. Hi from David. Oh, Clayton, VE3IRR says, added HackRF transmit receive switching to native GR Osmocom earlier this year. That's great news. Maybe we'll hear from him on how it compares. Timestamp on the debug messages. Yeah, it could be. I think. No, they're not timestamped anywhere. Richard Stanley says, awesome. Okay, Dave, N7LXR, did you use a microstrip connection from your connection to SMA out? No, I did not. I basically cut the trace and I soldered the leg of a capacitor to the cut trace, and then the other leg of the capacitor, I went straight into the coax. It's really tiny in there, so there's no way I could have, but I did use a microstrip on one of my first power couplers. It was a failed one, but anyway. David says, do you use 2-meter bandpass filter in the transmit RF? Absolutely. After the power amp, there is a filter. It's a pie-shaped filter, and from there it goes into the relay. Dennis, DL9 Cat, same question. Do you use filters? Yes, I do. Okay, any other questions?
Hi, Gavin. This is Richard. I love this demo. Thank you so much. I'd be curious about what some of the lessons learned were. Like, if you had to do this again, you know, how would you approach it? I'm looking at a similar, well, a use case in which you have the SDR, and it's in between the antenna and an ordinary amateur radio. So you can kind of use the SDR box as like a signal conditioner or a processing gate box or an antenna selection box or a whatever. And you seem to mention that maybe you wouldn't choose the HackRF this time. And so if you have any lessons learned to kind of share after you've done all this, which is amazing, that'd be great.
Yeah, that's an excellent question. So first, the HackRF, I mentioned early on that I chose it because it could transmit, but that was an uninformed decision. It can transmit, but only 10 milliwatts. 10 milliwatts. So in order to transmit anything and use it for amateur radio, you got to get up to 10 watts. So 30 dB of gain there. And so that was why I had to go with, cutting the trace and bringing out the transmit natively and so on. Other choices now, like the ADALM Pluto and the Lime, they already have separate connectors for transmit and receive, so it wouldn't have to do that. And some of the more expensive ones are natively full duplex, so you wouldn't have to do that. There were some lessons learned on building the power amp. I originally had thought that I would just monitor the signal level coming from the HackRF and switch the power amp on automatically. But because it's so low coming out of the HackRF, it was, it was switching over when it wasn't supposed to. And originally I was trying to switch the receive side as well, so just on one connector, but there was, enough positive feedback just in the open circuit relay contacts that the power amp was oscillating and so on. So, and that caused the power amp chip to blow up. So yeah, the lesson learned there is, use a radio that has separate connectors for transmit and receive. Don't try and do it with a half duplex single port connector. Sort of tangential to that, a lot of the problems I had with the power amp itself, because it was my first project, is to make sure your input and output are 50 ohms all the time, because otherwise the power amp chip will oscillate or self-destruct. And you have to do that even when the relay contacts or whatever it is, whatever switching mechanism you have is active, so you have to control the bias to the power amp and so on. So that was another lesson learned. And it was something in the software too. It was a lot of fun, but it was just full of bugs. And so I learned a lot about that. I'm not sure what the lesson was there. Anyway, those are the lessons I learned. Okay, there was some more questions zoomed by here. Let me go catch up. My name is Roger, student from PEI, CubeSat with ground station. Wondering if I get any assistance in regard to FSK modulation and demodulation. That's an excellent question, Roger. I played around with FSK modulation, and in fact, at the last talk, Barry gave a demo of FSK demodulation and modulation. So there's help available there. I don't know if you were the one who's asking, but you can send me an email or whatever. Derek to Roger. Okay, he's answering his question. And there's Barry saying exactly what I said. And so on and so forth. Christoph asks, if I understand this correct, you switch the HackRF to transmit by starving the transmit steam. And you're right, it is contrary to the recommended practice of HackRF, or of the GNU Radio concept. If you read the tutorials, they say, never starve your blocks. And if you write a block, not a tree module, it says, you should always try to produce output and consume the input as fast as you can, and so on. But that was, I had to go outside the recommended practice on that, or implement some other method. And I looked at messages. I looked at, having a button you push in the flow graph and so on. But the thing that actually clinched it is that the HackRF had this capability. The SOPI HackRF block that I found, even though it didn't work, it had that switch already built in. So I just expanded on that. So that was why I chose this. But yeah, you might be able to do a better job using a Qt GUI push button or something like that, or meshing stream. But you're still needing to switch streams on and off. So Clayton says, I did it. Start and stopping our receive and tree transmit flow graphs. Well, I tried that too. There was a deprecated switch block now. I can't remember what it's called, but and when you switched, it would actually stop the flow graph, rewire the ins and outs, and start it again, and disable the appropriate block. But that was just way too slow, and it had bugs, and so I didn't pursue that. But I did try it for a while.
I was wondering if you had investigated the method using USB relay boards. There are various USB relay boards on the market which use various chipsets.
Yeah, okay, so you're saying you buy a USB controlled relay and you could switch your transmitter and receiver that way. You could. You would then have to figure out how you're going to control that USB relay from GNU Radio block. So if these switches implement a serial protocol, then you could do that, I suppose. But you'd end up with, I'm pretty sure you'd end up with a custom block one way or another.
Yeah, I use this method with the USB board, and there are various libraries on Linux. I use a board which uses the FT232 chipset from FTDI, and there is actually Python code. There is a library called libftdi, and it also has Python wrappers. So I guess you could try using writing maybe a block. I don't know. So this depends on how you write your flow graph. I personally just use the libftdi code directly in my transceiver, but you can toggle the relays, and you can configure exactly which relays to toggle and when. So I find this method useful for a full duplex transceiver. So I have a line device at the moment connected, and when I want to talk, I just press a button, and then the relays switch on for a selected path. Say I have the amplifiers and the RF switch on a transmit path, and then when I stop transmitting, the relays will switch off, and therefore the RF switch will also toggle back to the RX path. So you can combine this. The board I have has 8 relays, so you can combine the relays and set up various, like you can have a multi-band transceiver this way. If you want, I can show you the type of relay I use.
Yeah, that might be interesting. I understand what you're saying, and it's a great idea. I would caution you, though, that remember what I said earlier. You have to make sure that your impedances at the input and output of each switchable amp are going to be controlled in 50 ohms. And if you've got to be careful how you turn on, bias your power amps so that they're not transmitting or powering up before the antenna switch gets to the desired position. But yeah, I understand exactly what you're saying. It sounds like a neat system.
Can I share my screen so I can show you a picture of the relays? I'm not sure. So there are various sources on the market, and there are various types of relays. Some of them use the human interface device, which has a separate library, and it's pretty difficult to identify. So I just want to show a picture of the relays. If I can share my screen. I have a picture of the relays here, the type that I'm using. It's using a chipset called FTDI FT232.
Yeah, I'm familiar with that chipset, and the relays might be interesting to see a picture, but I have a picture in my head, so I think Derek is the only one who can actually enable screen sharing. He had to do that for me, so he's.
Give it a try now, Adrian.
Can you see?
Oh, there we are. Okay, yeah, that's pretty much what I thought it would be. So those relays are they fast acting? Are they got good isolation? You know, that's the questions I would have. If you're going to use them,
So these relays are meant for home automation. You know, so they're for like switching 220 volts in home automation, so they can stand like a huge amount of current and large voltage. They're pretty fast switching, I think. They're I don't know, they take a couple of microseconds to switch. And the other problem is using some sort of RF switch. So there are RF switches on the market which are around 20 euros. Then you can combine. So I don't have any picture to show, but you can use multiple RF switches and just make up some sort of path where you can use multiple filters and multiple amplifiers for various bands. So right now I have like 4 bands configured. 4 bands starting with 2 meters and ending on the 13 centimeter band using this method. And this particular relay board, I don't know if you find this exact model on the market. I bought it like maybe 3 years ago, but it's very, very simple to program. So there's this FTDI library. Just give me a second. I can
okay,
show
Adrian.
you.
What Barry has said, everybody can put their comments and suggestions on the Talk Ham Radio page, so you could put all that in there. I would just reiterate that, you know, when you pick your relays, the relay I chose in version 4, which was the successful one, was an RF designed relay, and the pinout is important. It had shielding on adjacent pins and so on. It was designed to switch RF, whereas home automation relays, I'm pretty familiar with them too. And yeah, they might have voltage and current rating suitable for switching a bulb, but the isolation probably would be a key factor there. So any other questions?
Mike
Okay.
K7ECZ is asking, will the presentation slides be posted? We're happy to host those on the wiki if you're up for distributing them.
Okay, in fact, just a second here. I got to turn my receiver is still running, and it's okay. If you go to the Talk Ham Radio wiki page, in the agenda announcement for my talk today, there's actually a link where you can download the flow graph that I showed you in the GRC file extension. So you can double click on each block and see what's under it. And the PowerPoint presentation is also there. I think it's a PDF, but you don't really want to see the slides. So.
I've just pasted a link to that into chat.
Yeah. Okay, 10 o'clock, perfect timing. Anyone else? Well, I want to thank you for coming out today. It's been the highlight of my week, getting ready for this. So well,
we appreciate it, Gavin. Thank you very much.
Oh, and there's Vlad. Good to see you on there too.
Hi, Gavin.
So just before we lose too many of the participants, thank you very much, Gavin, for giving the talk. This is hopefully going to be a regular meetup, so please do keep an eye out if you're interested in more of these sessions. One of the things that we're very short on, though, is people to give talks and topics to talk about. So if you have ideas, please do respond via email, Twitter, wherever you saw the announcement of this in chat. And yeah, not to cut off Barry here, but we're also looking for people to help organize future meetups. This is something that we hope kind of becomes a distributed effort. So if anyone is interested in helping find speakers and helping schedule the events, please let Barry or myself know.
I would like to add one comment that Christoph had suggested. Not all of the demonstrations have to be live or original. You can actually find something you think that is interesting to our community. And part of what he suggested was that tell everyone to review it ahead of time and then have a discussion around that topic when we do the meetup. So that's another way of approaching this. So, and that's probably not nearly as much effort as what Gavin and I have gone to so far. But we learn more every time we do it, and it gets easier. But anyway, any suggestions along this line would be great. We probably won't do another one until January. Well, this is mid-December already, so it would make sense mid-January target the next meeting. So put your ideas on the Talk Ham Radio page or on the Ham Radio chat room so that we know what we can do next. And thanks again to Gavin.
And just two final shout outs. Coming up in January, we do have FOSDEM, the Free and Open Source Developers European Meeting. Usually it's in person in Brussels, but it's going to be entirely online. The topics in that session tend to run quite broadly. So we end up with, some industry research, some academic research, and then we end up with a bunch of ham material usually. So I'm gonna jam a link to that into the chat. That's the first weekend in February. And then next Thursday, there will be a general GNU Radio live stream giving kind of project updates and stuff like that. And Clayton, VE3 IRR, will be talking a little bit about some of the stuff that's come through GQRX over the last year, I guess. So thanks all for coming out, and it's the end of the main session. So thanks, folks.